A lot of people who try and get started in retro game development get really frustrated by having to spend hours downloading tools from the internet and hours more trying to get them to work before they can even write a single line of code. In this video, I'm going to explain how to use Visual Studio Code and something called dev containers to get up and running writing your own Master System games in about 15 minutes. That's less than the time that it takes for a cup of coffee to get cold. Now folks, when I say up and running in 15 minutes, I really mean from scratch, and to prove it, I'm going to start with a completely clean Windows 11 laptop. I'm just going to have the latest updates installed and my favourite web browser. Now, I don't usually use Windows, but I know that loads of you out there do, so I've got myself a really cheap refurbished Windows laptop to use for this demo. It's not super powerful, it has Windows 11 Professional Edition, but you can do this exercise on any operating system, including, of course, macOS and Linux. Now, if you're already using Visual Studio Code and you've already got Git installed, then you're actually way ahead of the game here. And if you happen to have ever used a dev container once on your computer, then you'll probably find that you can get through this in about 2 or 3 minutes. Okay, let's get that coffee on the go and start the timer. So the first thing we're going to do is we're going to set 2 downloads running. The first one's called Git, and that's a tool that we're going to use to download the sample project from a website called GitHub. The second thing is called Visual Studio Code, and that's a program that we're going to use to edit our game files and to build them into a final product. And we started off the Git download first because we really want that installed and ready to run by the time we start Visual Studio Code for the first time. When it comes to installing Git, I like to choose all the default options, except I do like to change the default branch to main instead of the more old-fashioned master. Everything else I just leave to the defaults. With VS Code you can just choose all the default options, no need to override anything if you don't want to. While we're waiting for those to install, I'm going to go to the Retcon85 GitHub page, scroll down until I find the template project, and then I'm going to copy the URL because we're going to need it later. Once we've made sure that both programs are finished installing, then we can launch VS Code. Now just for this demo, the first thing I'm going to do is I'm going to disable the AI features just because I don't want any pop-ups or suggestions while I'm recording the video. But you might want to leave these enabled if you do want to use AI. The next thing we need to do is download the demo repository. We click the Git button on the left hand side and click Clone Repository. Hopefully you also have your link on the clipboard, paste it in the box and press enter. We're now going to get asked where we want to save the project, so I recommend that you create a new folder under your home directory called Workspaces or Projects or something like that where you can put all of your software code. VS Code asks us if we want to open the repository and we say yes, and you can see on the left hand side here are all the files that have been downloaded. We're also asked if we want to trust the authors. Well, that's me, so obviously yes. After a couple of seconds, VS Code will notice that we've got something called a dev container in our project, and it will ask us if we want to install the extension. We'll say that we want to reopen the project in the container. Now we're told that we need to install something called Docker into something called WSL. And only for those who are interested, I'm going to explain what all these technical sounding things are in some gory detail towards the end of this video. So while we're waiting for WSL to install, we're going to download the last tool that we need, which is an emulator that we can test our finished game on. So I'm going to use Emulicious, which is a brilliant emulator, not just for Master System and Game Gear, but also for Game Boy, Game Boy Color and for MSX. It's developed by my good buddy Calindro and it's totally free to use, although you can support the project if you use it and like it. So I'm going to download the Java 64-bit version just so that I don't have to install any other dependencies to get it to work. Back in VS Code, I see that the WSL install is still going, so I'll wait for that to finish. And Emulicious has finished downloading, so I'm going to unzip that to a folder under my home directory called Emulicious. Once it's unzipped, I'll double click the emulicious.exe file to get it running. I do like to make sure that automatic updates are enabled in Emulicious because Calindro does like to release improvements quite regularly. I'll also increase the screen magnification, and I'll enable the option that automatically reloads games when they're changed, which will help me with the development workflow later on. Back in VS Code I can see that the WSL install is finished and we need to reboot, so I'm going to close down Emulicious, restart Windows, and I'm going to see you in a couple of minutes. Okay, we're back and I've relaunched VS Code, which has remembered the project that I had open before and is going to continue to try and open it. And since I forgot to do it last time, I'm going to pin VS Code to the taskbar because I'm going to use it all the time. So we're going to see the same pop-ups that we did last time about installing Docker into WSL. But this time we're a little further down the track and we see something about installing Ubuntu. This is the version of Linux that's going to be running inside WSL. This is going to take a few more minutes, so I'm just going to reopen Emulicious just so everything's all ready to go when we want to run our game. Okay, so now we're going to hit the one snag in this process. We're told that a user account needs to be created and we're going to be prompted to see if we want to reuse our Windows username. That's fine, and a password is randomly generated for us, but then we see the message command not found and everything stops working. I found that all we need to do here is to restart VS Code and everything picks up where it left off. I don't exactly know why we need to do this. I think it's some glitch in VS Code's install process. So we see the same familiar pop-ups, but this time we're on the home straight. Now that the Linux distribution has been provisioned, Docker can be installed on it. Remember, this whole process only needs to happen once. Once everything's been installed, then we should be able to open new projects again and again super quickly. Once the Docker install is finished, we just need to click continue to finalize it. At some point we'll see Visual Studio Code restarting in dev container mode. Now the screen will go blank and we just need to click show log to follow the progress from here. Now this is the final stage of the setup process, and what's happening here is that all of our SMS development tools themselves are being downloaded into the container. Each of these blue lines is a different chunk of the download. Now it's not actually terrifically obvious once the container download is finished, but you'll see this toast box down here on the right disappear, and you'll see the files from the project appear again on the left hand side. Okay, here we go. So now we're going to open a terminal from the main menu, and this is where we're going to type in all the commands that we need to build our project. We're going to build it by typing in the word make, M-A-K-E, and pressing enter. And after a few seconds you should see a new folder appear on the left hand side called build, and inside it a .sms file, which is our game. So we're going to go to Emulicious, navigate to find that file on disk, and open it up. And here we are, finally rewarded with just a magnificent Hello World game that will run on any Sega Master System. And we've just squeaked in under the 15-minute mark. Now let's see how that coffee's doing. I mean, not super hot, but... So just to prove that this game is really running the code from our project, we're going to make a small change to it and rebuild it. So we'll go back into VS Code and find the main.c file inside the source folder. This is where all the code for our game is. We're going to scroll down until we find Hello World, and being really careful not to upset any of the punctuation, we're going to replace it with something different. Then we're going to save our changes, reopen the terminal, and type make and enter again to rebuild. Flicking back to Emulicious, it's automatically detected the new version of the game and reloaded it, and sure enough, here's our new message on screen. Congratulations, you're now an official retro game dev. I said earlier that I'd try and explain what the programs we had to download and install actually did, so I'm going to try and do that now. Now, you don't need to know anything about how this stuff works in order to get going writing your own SMS game, so if you're not interested, just skip ahead to the next chapter. Visual Studio Code is what we call an Integrated Development Environment, or IDE, and at its core is a text editor. Nearly all software source code is plain text, and so we need a powerful and productive text editor we can use to efficiently create, open and save source code files to and from the file system. In this particular project, the most important source code files have a .c extension. We also downloaded a program called Git, which is a VCS, or version control system, and that's a separate program from VS Code which is used to help us keep track of all the changes we make to the source code. Git can also be used to synchronize source code to other locations, in this case a version of Git in the cloud called GitHub. Now Git was originally designed to be run from the terminal. That's a program that's used to interact directly with the file system and other programs rather than through a Windows interface. However, VS Code has its own Git integration, which lets it provide us with a more visual way to use Git in VS Code. That's what we did when we first cloned the quickstart repo before. VS Code also has its own integrated terminal, which works just like the native terminal, only with a few extra herbs and spices thrown in to make developers' lives a bit tastier. Both visual integrations like the Git menu and the integrated terminal normally talk directly to programs within your operating system. For example, we might have some build tools installed on our computer which we need to turn our C game source files into a fully working game image, and we might set up VS Code to call those programs in order to build our project. Doing it this way means that everyone who wants to build master system games would need to install all of their own tools, which can be quite time consuming and tricky. Dev containers is a feature of VS Code which allows us to import not just one program from the operating system, but entire virtual operating systems, which have already been prepared with any number of custom tools already configured and ready to use. For example, this project uses a dev container that I created specifically for building SMS games in C or Z80 assembly language. The container has access to the file system on your computer, so the custom tools can read your source files and write output files to your file system just like the local programs would. When VS Code is running a dev container, it goes into container mode. This means that the terminal as well as some integrations will run on the dev container instead of on your local operating system. To demonstrate this, we can open up a special local terminal, and if we type dir to see the files on disk, we can clearly see that the terminal is running on Windows. Running the same command in the regular terminal looks completely different because this terminal is running on a Debian Linux based container and we're seeing the containers file system rather than the host PCs. But what about all those other things we saw being installed? Docker, WSL, Ubuntu, what are all those? Well, dev containers are really just Docker containers with a small amount of Microsoft window dressing. Docker is a tool that lets us create containers based on images that we specify as plain old text files called Docker files. Here's what the Docker file looks like for the SMS toolchain container that I made. It's a long list of instructions for how all the various tools get installed, as well as references to other base images for lower level tools. If we follow all these references back, we'll eventually see that it's based on some distribution of the Linux operating system, in this case Debian 12. So we can see that a dev container doesn't just contain custom programs, but also what looks like another operating system too. Actually, that's not quite the whole story, and here's where it gets even more complicated. If you're running VS Code under Linux or macOS, Docker is just another program on the operating system. In this case, VS Code simply calls it to run the dev container. However, although our dev container does contain Debian Linux, it doesn't contain the Linux kernel, which is the very core of the operating system. In order to run the container then, Docker either uses the Linux kernel from the host OS, if we're running on Linux, or for macOS it uses a virtual Linux kernel. So on Linux or macOS, Docker is the only dependency that's needed to run dev containers in VS Code. On Windows the situation is quite different. We still need Docker and we still need a Linux kernel, but this time both the kernel and also Docker are run inside a virtual environment built into Windows specifically to provide Linux support, WSL, which stands for Windows Subsystem for Linux. WSL provides not just a Linux kernel, but an entire Linux distribution, in this case Ubuntu Linux. And that's why we saw first WSL, then Ubuntu, then Docker being installed the first time we tried to open VS Code in dev container mode under Windows. Oh, and if you're wondering how it is that the quickstart project is able to download the specific dev container that contains the SMS tools, there's a magic file in the project which contains a reference to my toolchain SMS Docker image. When VS Code sees this, it tells Docker to look for the image in Docker's default image repository, Docker Hub, and the image is downloaded from there. If you remember, that's what we saw earlier right after VS Code relaunched into container mode and we saw all those blue lines on the terminal. Well, that covers some of the super technical tooling stuff. Like I said, you probably won't really need to know how this works, but it can't hurt. Maybe more interesting is to look at the files inside the project. I don't have time to go into too much detail, but I can give you an overview. The first thing I'll say is that this demo wouldn't be possible without the awesome DevkitSMS project by the legendary Svet. DevkitSMS is a library that makes developing games in the C programming language for Sega 8-bit systems an absolute dream, and I bundle it as standard on my dev container image, but more on that later. Let's look at the folders we see in the project in VS Code. At the top is a folder called .devcontainer. Folders that begin with a dot usually have some special significance, and this one contains files that tells VS Code that there is a dev container associated with this project. The first file contains some VS Code settings, most importantly where to find the Docker image for the container. Here it references a local Docker file, which is the other file in this folder. This file is important because it's here that I instruct VS Code to use my SMS toolchain image for the project. From here it's also possible to add your own additions to the image if there are more tools you want to install over the ones I've provided, just so long as you don't mind learning some basic Dockerfile skills. The second folder contains something called a GitHub Action. I've added this to the project because it's a really cool way, if you're using GitHub, to get your game automatically building in the cloud, perfect for when you want to make official releases. I'll cover this briefly in more detail at the end of this video. Next is the .vs Code folder, which contains a bunch of settings that control VS Code's behavior for this project. I won't get into too much detail here, except to point out the task.json file, which lets you script your own actions if you want. I've added a few already to this project, including build, which runs the make command we saw earlier, and clean, which deletes all the outputs from the project to reset it back to just the source code. You can run these tasks by opening the command palette and choosing Tasks, Run Task from the menu. The build all task is set to the default build task, which means that you can run it even quicker from either its own command in the command palette or by using its keyboard shortcut. You might want to use this way of building if you find it easier than typing make in the terminal. We saw the build folder earlier. It was created the first time we built the project. It appears grayed out here because it's excluded from Git source control. Usually we only keep source code in Git and we don't keep the actual outputs from a project. If we want, we can clean the project to remove the build folder and the other generated files. We can either type make clean in the terminal or run the clean task in VS Code. The last two folders here are where the actual stuff that goes into the game are kept. The assets folder is where I advise putting things like graphics and sound resources. In the example, I have two sample sound files called bleep and bloop. The .fur files are the master copies I created in a program called Furnace. I exported them from Furnace to make the .vgm files, where the build scripts within the project automatically pick them up and build them into the game with tools from DevkitSMS. The make file you see here is part of what does this automatic building. I'd recommend leaving it alone unless you know what you're doing. Makefiles can be scary even for the initiated. The source folder is the most important folder of all, as it's where the actual source code for the game is found. Right now there are only 3 files apart from the makefile and only one that you'll likely need to edit, main.c. This contains what we call the entry point of our game, the place where execution starts. In the file I've added some very basic structure as well as the example hello world demo code inside these blocks that I've commented to make it clear. If you were to delete the code inside these blocks, you'd get back to a game which basically does nothing at all. The example blocks live in 2 sections of the C code called functions. The code inside game init is run just once, when the game first loads, and the code inside game tick is run continuously every time the screen redraws, which is either once every 50 or 60 seconds depending on whether your emulator or real console is a US region model or not. You'll probably find that you can achieve most simple things that you need to just by modifying these 2 functions. If we look at the example code, we can see some simple functions being called. The ones beginning with SMS underscore are all calls to DevkitSMS's main library, SMSlib, which makes the console do stuff. And the ones starting with PSG are calls to DevkitSMS's PSGlib library, which is specifically designed to play audio files inside games. I won't get into a line-by-line explanation of how the example works right now, but the template main.c does have some handy links to the documentation for DevkitSMS at the top. As a final quick bonus, I'll really quickly show you another workflow that lets you build your SMS files completely in the cloud without even needing any dev tools locally. As we saw earlier, the .github folder in the project source contains something called a GitHub Action, which means that the project's already set up to automatically build on GitHub. So all you need now is to create a new repository in your own GitHub account using the quickstart project as a template. If you do it this way, then you're much better off copying your own repository URL rather than my original one when it comes to cloning this onto your computer, as we saw at the beginning of the video. As soon as it's created, you should see a build starting, and after a short wait you should be able to download the built ROM as a .zip file, which you can open directly in Emulicious. You can also use GitHub Actions to create official releases of your game. One way of doing that is by going to the releases page on GitHub for your repository, creating a new release and giving it a version number. This will start another new build, and once it's finished, the .sms file will be automatically attached to your release. Just be aware that if you want to do this, you might first have to go to your repository settings and grant GitHub Actions read and write permissions for your repo. If you want to, you can use these GitHub Actions to develop completely in the cloud, because you can edit any file that you like directly in GitHub. But I'd say that's a pretty slow way of doing things, because you'd have to wait a long time for every build, every time you made a code change. It's much better to be able to quickly run builds in your local environment every time you want to test a change. And there we have it. If you'd like me to do some more videos about how to use DevkitSMS to write your own Master System games, then let me know below. Otherwise, as usual, if you've got any questions, comments or suggestions, don't be shy, just give me a like, subscribe and hit up the comment section.